Good morning, folks. It's May 9th, 2020. I'm Jim Hodson with the Fort Worth Aviation Museum, and here today again with Garry Goff. And Gary's going to join me today as we go around and we talk about one of our rare airplanes that doesn't get love, and that's the TF-102 Delta Dagger. So at any rate, this airplane was originally designed and built early 50s, and we're going to talk a lot about the engineering of this airplane as we go around today. But the airplane was the first Delta Wing supersonic airplane that the Air Force had. So we're going to walk around. This is the training version of the 102 called the TF, and Garry was talking about some of the engineering aspects of this airplane earlier. So why don't you give us a little bit of a brief, Garry?
The word of the day for this airplane is going to be vortex generators. Vortex, V as in Victor, O as in Oscar, R as in Romeo, T as in Tango, E as in Elephant, X as in X-ray. Vortex generators. And you can see those vortex generators that are on top of the canopy at a couple places. The reason why they have these is the original TF-102 had a buffet problem when it approached supersonic. It was very disturbing how much the aircraft would buffet. And so, and you guys can research this and search on the internet what a vortex generator does, but the vortex generators allowed the air that was separating from the canopy, from the aircraft, causing the buffeting to stick to the canopy and stay with the aircraft so that it could approach supersonic. But unfortunately, even with all that, the aircraft straight and level could not go supersonic. It could only go supersonic if it was in a shallow descent.
All right. So we've seen those on the other airplanes. They've usually been on the wings,
right?
But not here, the way we've got them here today. So this is different. And my gimbal has decided to be spastic again today. So hopefully I don't jitter too much. Again, this is a Delta Wing airplane, and that was different than what we were flying at the time, isn't it?
Much different.
And you were mentioning something about the B-58 and the Delta Wing on this airplane. What was that all about?
The interesting thing about the F-102 design at I just forgot who built it.
Oh, this was Convair.
Convair, yes.
Well, the nose of this airplane was actually built here in Fort Worth and then shipped to California, where it was mated with the rest of the airplane.
And what Convair did when they built this aircraft, and they figured out how to make it go supersonic, which we'll talk about later on, which is amazing what an engineer, one man engineering, figured out how to make the aircraft go supersonic easily, is that this wing here that you see is the exact same wing, but much larger, on the B-58 Hustler, the supersonic nuclear bomber that we had for about 10 years operational. And that's what's so amazing, is that this actual wing here is the same wing, the same shape, everything about it, that they took it over and was able to get the B-58 to fly supersonic.
Sorry about the jiggling here. Some reason this gimbal has done it again. It's decided to have a mind of its own. Not sure why it's doing this, but I'm going to just have to do a little bit of a handhold on it. So I know you talked about the buffeting of the nose. As part of the engineering to solve that was the wingtip here. They drooped the wingtip a little bit so that it would give it more stability, because I guess they had problems with visibility from the airplane.
Because of the aircraft, the original wing was Model 10. And that was basically a straight wing with a little bit of an up bend. And as they began to fly and do more test flights, they found out if they were to bring the wing down, kind of like what we talked about a couple days ago with the F-18, how the front of the wing slopes down, that allows it to fly better at slow speeds, which allows the pilot to land the aircraft in a much more safe way so that the nose is not so high pitched to land. It's interesting to note that the wing, the way it swoops down, and the speed brake has been enlarged. Both of those two were also done here at the factory at Fort Worth.
Okay, and Enrico's asking, says this aircraft has the Coke bottle shape, right? So let's see if we can give you a view of that from the back side here. because it does, and this was the original airframe that had it. You can probably see, should be able to see it right here, the way it dips in and then back out here by the engine. If we've got a chance, we'll show you the F4. There's an F4 sitting next to us, and it's very extreme on that one. There are only, although the Air Force ordered about 120 of these, only about 69 of them, 62, 69 of them were actually ever delivered to the Air Force. And during Vietnam, the Air Force actually attempted to use this airplane as a forward air control airplane. The Marine Corps started the Fastback program with TF-9s and then went to TA-4s, but the Air Force actually started with this aircraft primarily because it had two pilots, so one could be an observer outside, and the other thing being that part of its armament was 2.75-inch rockets, which have been traditionally used by forward air controllers for a long time to mark targets.
And speaking of the Coke bottle shape, that was when the aircraft first came out, the prototype for the F-102, it could not go supersonic. And the problem was the Air Force required it to be an interceptor to go supersonic, to go against the Russian Bear bombers and get high altitude real fast and be able to deploy their weapons to stop the Russians. Well, this gentleman, Richard Whitcup, he was a tinkerer his whole life. And he is the one that is revolutionized modern jet supersonic aviation, because from his tinkering with the different models in the wind tunnels, he came up with the idea of having the fuselage, which is the body of the aircraft, to be pinched in a little bit near the aft ends of the wings, and it looks like a Coke bottle, the old-timey Coke bottles, and you can go research that and see what we're talking about. And he came up with this concept of engineering area rule. Area rule now is the mainstay of how all fighters are designed to be able to easily go supersonic. And when they did that with the F-102, it was actually able to go supersonic in the climb, which the Air Force just loved.
Well, in this particular airplane, even though the 102 was supersonic, the TF was never able to be supersonic because of the nose, right? Mm-hmm. We got a couple of things here on the wings that we have not seen in some of the other airplanes. And they look like little winglets or fences or something. What are these?
That's it. They are a wing fence. They are used for to keep the airflow on the wing from separating when you're at high angles of attack.
So they're kind of like a giant vortex generator.
There you go. Giant vortex generator.
Okay, now there's some interesting stories about this airplane when we acquired it. This airplane is on loan through us through the General Services Administration, the Surplus Property Program. This airplane was at a museum down in South Texas, and we were trying to figure out how we were going to get it here. And so we finally decided that the only thing that was feasible, since we had no equipment to operate with down in South Texas, was to get it apart a little bit, put it on a trailer, and haul it up here on a trailer. So we had to do a number of things where that was concerned. We found out, first of all, that wide loads on cargo has to be 32 feet because it has to be able to clear bridges, and that we also had to have that permit all the way from South Texas up to here. So we did that, put it on a flatbed, and brought it up. And there were many surprises for people in many communities on the way up. Not only was it a surprise to see the airplane, but what they found out is some of their signage and mailboxes were not clear of the highway like they were supposed to be, because we took out something like 12 or 14 mailboxes and signs along the way. Got stopped by the police, I think it was 8 or 10 times, but we always had the permits, we were always correct. And then the one big surprise, and we've got a picture of this, I think it may be on our website, is this airplane, we had to take the wingtips off so that it would be 32 feet to clear the bridge. We've got a picture of this airplane with a 32-foot wingspan with the 32-foot wings hanging over a bridge that's supposed to be 32 feet wide. So some people in Ned County got a surprise because they found out that their bridge was narrower than it was supposed to be. Now we've also been told that these airplanes were used for B-58 trainers, and the most noted, obviously, is for training 102 pilots. And we're going to take a close look at the signage here, because this one is important. Now, first of all, this airplane has a name like a lot of the airplanes that we have here, And this one is called Huey because it was in a squadron with the Louisiana Guard for a while. And so it's Huey after Huey P. Long. Now, other than that, you may notice underneath there, underneath the Huey, is a presidential seal. And we are very proud of the fact that this airplane, oh, hold on, no, we're going to get that, I'll come back to the question, that this airplane is a presidential airplane. President Bush flew this airplane 3 times while he was going through 102 transition down at Ellington Air Force Base. So the airplane's been kind of an ugly duckling, and it's sitting back here in the back lot without a lot of attention. And we'd certainly like to get it restored at some point in time, but we have never been able to find enough support to do that. This one is going to be an expensive airplane to restore. But it is a presidential airplane, and it's one of the few that's above water. Let's see, I've got a question on here. What would be the minimum speed for a fastback? You know, that kind of depends on the airplane and the mission. But we did some in OV-10s, which is not a fastback airplane, of course, but we would operate around 200 knots or so. The jets, because they're usually going to be operating in a high threat area, are usually going to be around 250, 300, or even faster. It really depends on the mission and the threat in the area and the altitude that you're flying at. So anybody else got any other questions? Or is there anything that you'd like to see close up on this airplane? I think we'll take a walk over here to the F4 because we've got one right next door, and we'll show you the Coke bottle effect on the F4. So this F4, and we talked about this in an earlier video, it says Navy and it says VF202 on it, but any of those of you who are very astute can tell by the tail number that it says 64-0825. John Calvin. Hey John, how are you? That is not a Navy bureau number, and this is painted up as a Navy airplane. Well, the thing is here, this airplane belonged to the 301st. It is an F4C that was being used as a maintenance trainer. I'm going to show you a little bit of that. We're not going to spend a lot of time on the F4. But when the Air Force was done with it, over at Carswell, the Navy transferred it to them, and then they could paint it up as a gate guard. And by the way, our TF-102 was the gate guard down at Lackland Air Force Base for a number of years. So we're going to walk up to the front of this so you can see the Coke bottle effect on this airplane. You'll also notice the strut on the nose is pretty well extended. That's not as high as it would normally be to go off of a carrier. This wasn't a carrier airplane, but that strut would be extended almost all the way up, so it would really have the nose pitched up. We'll show you one thing here. We do not have the maneuvering slats and flaps on the leading edge of this airplane, like we did on the naval F4 that we looked at, and on the tail it doesn't have the slats either. But we're going to come up front so you can see the Coke bottle effect on the F4.
It can't emphasize the revolutionary engineering design that Richard Whitcomb basically invented, and it revolutionized all jet fighters, and every one of them has some type of that pinch called the area rule, or what we call a Coke bottle effect, to be able to go smoothly through the sound barrier, because it truly was a barrier. Without it, you could not get through it unless you used an excessive amount of power. But with this Coke bottle design, you don't need a whole lot of power to go supersonic in today's modern jet fighters.
Okay, let's see if we can get a better view of it on the other side. We may have a little bit better light. We don't trip over everything that's out here.
See how it goes in? You can see how it goes in from the intake.
Can you all see that? Navy nose on the F4. Actually, this is it's an F4 Charlie nose. It may be a Navy nose, but we're not certain about that. It could be. But here's what the 301st was using it for. If you'll notice, we've got some patches on it with a lot of rivets. And we're going to show you some more of those. This airplane was used as a combat maintenance trainer over here at Carswell, so that the maintenance people could learn how to put patches on the airplane.
With battle damage or whatever happened, to be able to repair the aircraft in the field so that it could go out and do its mission, its combat missions.
And so one day, if we're lucky and we can get the support that we want, we're going to put this airplane back into its Air Force Vietnam or Southeast Asia colors, which would probably be the camo color. And then there was one other thing, as long as we're here by the F-18, I wanted to show you again. I'm not certain we were clear on this the other day. We talked about, in the TF-102, almost forgot about this. Since we're right here, we're going to go ahead and do another quick peek back there. We didn't talk about something that's missing on this airplane. Hate to be running around in circles with you folks here, but that's okay. It's Saturday. Okay, what's missing on the tail? We've got a delta wing, and we've got a tail, and we've got speed brakes, but what are we missing? No elevator. There's no elevator on this airplane because this airplane had what are referred to as elevons. So the ailerons on the back of the delta wing here also serve the function of an elevator for the airplane. So they were able to remove it off of the tail, which I'm sure helped with the speed because it's less drag that way. So that was something special about this airplane. I wanted to make sure that we showed you. So without getting you too dizzy, we're going to go back to the F-18 because we talked a lot about the maneuvering flaps and slats on that airplane and the way it changed the camber of the wing. But one of the things we want to make sure that everybody understands is that that's not the normal configuration. With the leading edge flaps and slats down, the camber of the wing is changed for slow speed flight going aboard the aircraft carriers or landing in general, or when they're fighting. So it's got this huge camber which changes the chord line on the wing, but in normal flight, both of these surfaces are going to be up and the wing is going to be straight.
And thus it can go real fast. And for those who do not know what a camber is you can see how the how the wing is shaped with a big curve. What happens is when an air molecule hits the front of the wing and travels over the top of the wing to meet up with the air molecule that's going underneath, which is going really fast because it has very little drag, it takes a lot of speed to go over the top and match up with the molecule at the tail, the back end of the wing. And that speed over the top is a low pressure. And the constant speed underneath is a higher pressure, and that's what causes the lift. That's how the aircraft actually goes up. And so this allows the aircraft to maneuver at all different high angle of attack attitudes, which makes it an excellent, by far excellent dogfighter.
Well, and one thing, let's turn back around so we can look at the F4 again. One of the things I wanted to mention the other day is that when you're doing air combat maneuvering, you're not looking inside. You're not looking at your gauges. You're not looking to see what your altitude or your airspeed is. If you've got a REO in the back or a weapons system officer in the back, they may be looking at altitude and floor, but you're not. You're outside because we got some rules when you're fighting airplanes. And one is lose sight, lose the fight. So you've got to be outside. So one of the things you're looking for are your tactile feels of the airplane. I can tell you with the F4, the tail of the airplane had what was called a high and low pressure on the tail of the airplane, depending on the speed. So you'd be fighting the airplane and getting slow, and the airplane's tail would actually flutter just a little tiny bit, just enough that you would notice it in your feet, and you'd know, oh, I'm at 150 knots. And so there were different things with the airplanes, and I'm sure, Gary, you had stuff with the F-15 that were similar to that.
And it's so important what Jim mentioned about the tactile feel of it. When the airplane starts shaking or doing something, you know what speed that the aircraft is going because you don't have time to look at your instruments. And that speed will determine whether or not I can go up over the top like a loop type thing or any other types of maneuvering based upon that speed, because we know what it takes to go over the top in a loop maneuver, which is very critical in dogfighting.
So we had some other rules too besides lose sight, lose the fight. One is you wanted to angle off on your target as much as possible. Speed is life.
Speed is life.
And what are some of the other ones, Gary?
We had one that Are you a nose position or an energy fighter? A nose position is like what this F-18 could do. It could get slow and just move its nose anywhere it wanted to. Or you could be a energy fighter, which means you stay at a higher speed. The bad news is you're also going to be at a higher G all the time. So a high-speed fight is going to be one in which you're sitting at 7 Gs to 8 Gs a long time. Whereas a slow-speed fight, it'll get down to 1 or 2 Gs real quick.
And we used to refer to that as keeping your Q up.
Q, that's right. Keep your Q.
Keep your Q up. And somebody just asked about the fence on the tail on the 102. I'm not exactly certain why there would be a fence on the tail, other than probably controllability when the nose is up for takeoff and landing.
Yes.
So it would maintain an airflow across the control surface of the tail. Otherwise, it'd just spill off the top, and you'd probably lose rudder control.
Right. Right. So today is more of an engineering day.
Yeah. So we're kind of getting close to our time limit here. So does anybody have any other questions that they'd like to ask? Tell me about, I can't read that. Tell me about the Lex. Is that what it says? Can you tell me? Daniel,
I'm blind as a bat.
Okay.
That's why I'm a pilot.
Oh, the leading edge extensions. I'm not sure. We talked about those the other day, Dan, but those are obviously here as part of the control surfaces on the FA-18, so that they are flying control, not just a landing control. So it was, as Gary talked about the other day, so that it could be used in flight as part of the dogfighting regime. So let's see if we've got any more questions. Did the TF-102 have a drag chute? Yes, it did. And that was right inside that tail compartment, that part that sticks out above the exhaust. The flap, that was the speed brakes, and also the drag chute was positioned in there.
Yeah, on landing, what they would do is they would pop the speed brakes out to help slow it down, and then he would flip a switch, and the drag chute would come out to slow it down even more. Because as a Delta Wing airplane, you have to maintain a little bit higher speed on landing. So you'd run out of runway.
We talked about the Sidestick Controller, right?
Oh, the Sidestick Controller. That's an interesting thing. In the later model F-102s, I just found this out. I did not know this. But they, when they put the new radar scope in there, it was so big that they had to remove the stick controller out of the cockpit. So they came up with this revolutionary idea, and that is to have a side stick. Of course, that's what the F-16 is famous for, but the F-16 owes that design concept from Convair and the idea of having a side stick. And the acceptance pilot for the Air Force was a 2-star general that was flying it, which that would never happen in today's world. But he took the aircraft up, and he said he really enjoyed the side stick with no problem. He could see the radar scope. Everything was just good to go. The only thing he said, you needed to have an elbow rest because your elbow got tired after a while flying side stick. And so that's how they came up with that. And of course, General Dynamics then used it for the F-16. And other airplanes now fly with side sticks.
Okay, and 102 said, did it have an internal or external start?
It's an internal start, and I can't remember what it was.
It may have been a shotgun start. I'm not certain.
Yeah,
It had
something like that, yeah.
It had a J57 engine in it. And I guess here's one of the last bits here. If any of you are personal friends with former President Bush, please let him know we've got one of his old girlfriends here, and we would be delighted to have him come out and reunite him with an airplane that he flew on 3 different occasions.
You know what else is interesting about the 106? All the weapons are internal. The doors would open up, and then you'd fire your missiles, and the doors would close.
Well, we can show them those doors as
kept it really
kind of a last
sleek,
thing.
Kept the jet fast, was able to do a lot of intercepting kill missions because, and you can see the rectangular shaped doors here that it would open up, so he would carry a set of 3 pairs, so that's 6 radar missiles that they would use to launch against bad guys, the Russian Bears. It could also carry a nuclear-tipped missile that they would fire and have an area explosion that they they actually tested it out, and it actually did work back in the 50s. And 1957 is when they made the mods to the airplane here at Fort Worth.
So again, this airplane here today was the TF-102. It's probably one of the undertold stories here. It's in kind of the back of the lot. needs a lot of help in terms of restoration and work, but it's a fascinating story. This again is like the T-33, where it is one of the initial airplanes that led the way for some of the more modern airplanes. And again, it's part of the Fort Worth story. With these things being built here, Fort Worth has had so many firsts, so many innovations in aviation and aerospace. That's why it is one of the leading areas in the world. So once again, I'd like to thank you for being with us here today from the Fort Worth Aviation Museum, home of the most touchable warbirds in Texas. Thanks for joining us today, and we hope to see you again in the future.